Hello everyone, welcome to lesson 76 of our Golang course. In this lesson, I'm going to introduce you to channels. Channels are one of the most talked about features of Go. So let's get started. In Go, channel is a synchronization primitive that is used to transfer information between two parts of your program, which are usually two Go routines. They can be used to pass data between two or more Go routines. Channels encapsulates Go's philosophy of sharing memory by communicating instead of communicating by sharing memory. The two parts of your program don't need to know about each other, but they are sharing memory by communicating via channels, as they both have access to the memory where the channel exists. This is how you would declare a channel. Here, we are creating a channel of type string. So we use the keyword chan. As you can see from here, channels are typed as well. So you need to specify the type of value that the channels will hold when declaring a channel. Channels are created with the make function. Let us look at initializing channels with code examples. First, I'm going to create a integer channel. Here, I'm declaring integer channel which is of type int. Now let's assign it a value. We will use the make function to create a channel. So we can do make and inside it the chan keyword, then the type which is int. Instead of doing this, you could do something like this. Here we are declaring and initializing the channel in the same line. So this is basically how you would create a channel in Go using the make function. The channel that we created in the example is a bidirectional channel. That is, you can send and read data from it. You can create a unidirectional channel by using the arrow dash operator. The placement of the operator decides if the channel is read-only or write-only. When the arrow dash operator is placed in the front of the chan keyword, it indicates that you can only pull values from it. That is, it's a read channel. So what we have here is a read channel, since we have the arrow dash in front of the chan keyword. Similarly, when the arrow dash operator is after the chan keyword, it indicates the channel is a put channel or a write-only channel. What we have here below is a write channel. Let us now look at some examples of unidirectional channel. First, I'm going to create a read channel. As you can see in the read channel, I'm placing the arrow dash in front of the chan keyword. That indicates that read is a read-only channel. Now, to create a write channel, we will place the arrow dash behind the chan keyword. So this is how you would create a write channel. We place the arrow dash behind the chan keyword. Please note that both of these channels are integer channels. That is, you can only pass integer values through the channel. You won't see unidirectional channels initialized like we did in the example very often. They are mainly used as function parameters to indicate that the function expected a read-only or write-only channel. Channel conversion is implicit. That is, you can implicitly convert a bidirectional channel to a read-only or write-only channel. Let's create a function that only accepts a read-only channel. Here, as you can see, the read-only function has parameter c, which is a read-only channel. Now, if I create a channel here and say int channel, as you can see, I have created an int channel, which is a bidirectional channel, as I'm not using the arrow dash operator here. Now, I can call the read-only function by passing in the int channel. This is because, as I mentioned, the conversion between bidirectional and unidirectional channel is implicit. Similarly, we can convert it to write-only. Move this to the back, and as you can see, this too works because convergence from bidirectional channel to unidirectional channel is implicit. Now let's move on to reading and writing to channels. The arrow dash operator is also used to read from or write to channels. Again, the placement will decide which operation we are performing. To read, you place the arrow dash operator on the left of the channel, and to write, you place the arrow dash operator to the right of the channel. As you can see here, I'm reading the value into the value variable using the arrow dash operator in front of the channel. And then in the second example, I'm putting a value 10 by using the arrow dash operator on the right of the channel. Please note that it is an error if you try to read from a write-only channel or if you try to write to a read-only channel. Now let us understand reading and writing using an example. Here we have the int channel. So I'm going to create a Go routine that is going to write to the int channel, and then using the arrow dash operator, put a value of 10 on the channel. Now, this go routine will put a value of 10 on the channel. In our main go routine, let us read the value from the channel. To read, we start with arrow dash, that is on the left of the channel. So this is how you would read a value, and this is how you would put a value on the channel. Now let's run the code and see what happens. And as you can see, 10 was printed through the println line. The operations of reading or writing to a channel are blocking operations. This means that if you are reading from a channel that does not have data written to it, the read call will block. That is, the execution of the coroutine that is reading from the channel will block. And this is exactly how our previous example worked without wait groups that we used to make sure that all go routines execute. So this here is a blocking call. Our main function won't be executed completely until we have a data to read from in channel. If I do this and don't write to the in channel, let us see what happens. And as you can see, there's a deadlock because this call will block indefinitely. This also means if a go routine is trying to write to a already full channel, that call to is blocking. This is where you need to be careful about the blocking when working with channel, as this can cause a program to deadlock, as we saw in the example. Now, let's move on to closing the channels. Channels can be closed with the close function, which is a global function. Now you may ask what happens when you read from a closed channel. It is not an error to read from a closed channel. Then, how would a caller know that the channel is closed? When reading from a channel, two values are returned. First is the read value itself, or the value that we read from the channel. The second value is a bool indicating if the read value is what was written to the channel, or a 0 value for the type, which is sent back when the channel is closed. Again, let us understand this with an example. Let us save the read value into a variable, and as I told you, there are two values returned when you read from a channel. Second is the bool indicating if a value that is returned was written to it, or if it's a 0 value. Here, I can do fmt println read value, and then second, print the value of OK. Now let us close the channel with the close function and pass int channel. That is, we are closing the channel. I'm just going to copy paste the print values. So here what we are doing is creating a channel, writing to the channel through a go routine, reading a value from it, closing the channel, and then reading the value again. Let us now run the program to see what happens. As you can see, 10 was printed and a true value was returned. That is, 10 is a value written to the channel. Then we got 0, which is a 0 value for int type, and then false, which means that the channel was closed and the value returned is a 0 value for the int. So you can read from closed channel as many times as you want. To indicate the value returned is from a closed channel, the second returned bool value will be false. We can also use the for range clause to read from channels. The range clause will exit when the channel is closed. When ranging over the channel, a second value is not returned. Instead, the range group will just exit when the channel we are reading from is closed. In Go, the closing of channel is used as an indication that a condition has been met, just like sync.condition object. Let us now look at an example of reading from a channel using the for range clause. So here, I have modified our program to first create the channel, then in a Go routine, write values or 5 values to the int channel, then close the channel. Underneath, we are running a loop to read from the int channel and then just printing the value. If we run our program now, you should see 0 to 4 printed to the console. And as you can see, 0, 1, 2, 3, 4 is printed to the console. So that is exactly how you would range over a channel. Again, the range clause exists when the reading channel is closed. So if I do this, we should expect a deadlock. And as you can see, we do get a deadlock. Now, as I told you, the closing of channel can also be used to indicate that a condition has been met. Let's look at an example. So here, in our example, first I'm creating a signal channel, which is of type any. Then we are creating a wait group just to make sure that all our Go routines are completed. So then I'm ranging over 5 to create 5 Go routines. We are reading from the signal. That is, this will be a blocking call, and 5 of our Go routines will block here. Next, we close the channel. That means this will return a 0 value and our Go routines can finally exit. So here we are using the signal channel to indicate a condition has been met by closing the channel from outside the Go routines. Let's run our program and see what happens. And as you can see, all 4 will able to exit. Now let's move on to buffer channels. When creating a channel, if you specify the capacity of the channel, it will create a buffer channel. That means the call won't block until the channel is full. So as you can see here, I am creating a string channel which is of capacity 2. So this is essentially a buffer channel. So you can write 2 strings before getting blocked. When creating a channel, if you specify a capacity of 0, it is equivalent to a unbuffered channel like the ones we saw earlier in the examples. Please note, if the buffer channel is empty and you write data to it and a reader is reading from it, the data will be directly passed to the reader without going through the buffer. So that is where buffer channels are useful. We usually use buffer channel when we know how many values we are going to write to the channel. Next, let us look at nil channels. The default value of a channel is nil. Reading and writing from a nil channel is blocking. If you try doing that, the Go runtime will tell you that a deadlock has happened. This is because the program is stuck reading or writing to nil channel, which is never going to happen. Please note that closing a nil channel results in a panic, so make sure your channels are always initialized. So if I say it is a channel of type string and then we print the value, you should see nil printed to the console. And as you can see, 0-0 is printed, which is the address of nil. Now if I try to read some value from a nil channel, you will see we will get a deadlock. And if I try to close it, our program will panic. As you can see, our program panicked, saying we are trying to close a nil channel. When working with channels, you must have a clear ownership of channels. You need to clearly define who the writer or producer is and who the consumer or the reader is. This helps prevent any unforeseen errors. The writer should be responsible for writing and closing the channel. The reader should be responsible for reading and handling the condition where the channel is closed. So in this lesson, we saw channels are an integral part of Go's concurrency model. It is used to implement Go's philosophy of sharing memory by communicating. We also looked at bidirectional, unidirectional buffer channels. That's it for this lesson. I hope you enjoyed it. If you have any questions, please post a comment under the video or reach out to our Discord server. Until next time, happy coding.